Polynomials are the language of algebra, a very important tool used in science and engineering. Here we've got some engineers working on some stuff. Looks like an automotive plant or something going on there. And lots of polynomials, lots of algebra going on in all areas of math and science. So let's see. Looks like we got some things here we can learn about adding, subtracting, multiplying polynomials. So let's dive in here. How do we work with these polynomials? Polynomial, once again, is an expression, an algebraic expression that has variables and coefficients. This number in front of a variable is called a coefficient, and constants. All right, and each of these are called terms. So there's two terms here. That's a binomial. Two terms here. That's called a binomial. We're going to add them. Now, there's two ways to do this. All right. There's a vertical way that's kind of, if we have trouble, we can see that we can take these 5y plus 4. We're going to add negative 2y plus 6. So we can stack these here. All right. And if we stack them like this just reminds us that we can add the variable terms. So here they got to be like terms, same variable, same exponent. 5 plus a negative 2 is a 3y, and then we have a positive 4 and a positive 6, and we're adding these. That's a positive 10. So that's kind of a nice way. You want to move away from that as soon as possible. This is going to be your preferred method for the long haul, the long term, that is, all right? So this is preferred. So when we're looking at this horizontal, we can keep it in this form, and you can do a lot more with it. So if there's a number out front here, we got to distribute that. Right now, there's an invisible 1. If you want to think of it as a 1 right there, sometimes that's useful. And if you distribute a 1, it doesn't really change it. So we have d minus 9. We can pretty much just erase those parentheses. Now, there's a number in front of here, and this one is useful to think about this. There's like a 1 there. And if you want to think, remember, subtracting is the same as adding a negative. Remember that from your algebra experience, hopefully. So subtracting a number is the same as adding a negative. So we can distribute that there, and we end up with negative 1 times 3d is negative 3d. Then we have negative 1 times negative 1. That's a positive 1. All right? And so now we can combine these. D minus 3d, that's negative 2d, negative 9 plus 1. Don't forget this negative sticks with that 9 there. Negative 9 plus 1 is negative 8. And so this term up top, and we should have some equal signs. This expression is equal to this expression is equal to this expression. This is what we call simplifying. All of these are worth the same, but it's simpler when we write it in this way. Here we have 4 terms. Here we have 3. No, I'm sorry, I can't count. Here we have 2. Counting is important, right? All right. So now we want to find some sums of some larger ones here, all right? Well, we can do the same thing, okay? And then we want to find that, we want to write it in standard form, all right? So you can pause the video here and try this out. Pause it and try these out. Come back, and we'll see if we're understanding. Remember, add like terms. So if we have squareds, those get added. We have end of the first, and then we have some constants, all right? So go ahead and pause and try these two. See if you can simplify them. So hopefully you made some progress there. Now on this guy here, we've got 2n squared minus 5n minus 6. And then, because there's nothing to distribute, there's an invisible 1, but when you multiply that doesn't change it. So we have plus a negative n squared. Well, we'll write that as just a minus n squared. Adding negative n is the same as subtracting n. Okay, minus 3n plus 11. And so now we're going to combine like terms. So even though they're not necessarily next to each other, we can combine the things that are the same variable and the same exponent. So we have 2 minus 1. There's an invisible 1 there. So that's going to be a 1n squared. You don't have to put that 1. You're welcome to if you want. Okay, we've got some n's there and some n's there. Now watch out. There's a negative here and a negative here. So negative 5 minus 3 gives us negative 8. Then we've got a negative 6 plus 11. Negative 6 plus 11 is a positive 5. And so there it is. Okay, that's our solution. That is in standard form. Remember, standard form means the exponents on the variables are getting smaller, all right? So the exponents are getting smaller there. All right? So, how about this? We're going to add here. All right, same idea. Combine like terms. Now, notice, again, there's nothing besides a 1 out here. If there were numbers out here like a 2, then you would have to change things and would multiply that. So 3g squared minus g plus 3g squared minus 9g plus 4. Combine like terms. If you haven't had a chance to do this, pause and try it out. Combine the 3g's, that's going to be 6g squared. We have a negative 1g. Remember, there's a 1 there. And a negative 9, that's negative 10g. And then we've just got a plus 4 over here. That's all we've got, okay? So that's our standard form, all right? So now let's back up here. The degree is the greatest exponents, all right? And so here the degree is 2. Here the degree is 2. In term, this is really the leading term, okay? The leading term is this first thing in front. So the leading term, no typo there. The leading term here would be n squared, and the leading term would be 6g squared. And that leading term there is an important thing because that tells us a lot about what's going on with the polynomial. So, all right. All right, here's a couple subtraction ones. Maybe pause and try those there. See what you can come up with. Now, remember with these guys, we've got an invisible 1 there, so we can just erase those parentheses because the 1 doesn't do anything. Here we got a negative 1. We've got to distribute these. That becomes negative 7x and minus 1. So distribute negative 1 times 7x, negative 7x. Negative 1 times 1, negative 1. All right? Now let's combine it. We've got 6x minus 7x. Well, 6 minus 7 is negative 1x. 9 minus 1, that's 8. Okay, so our degree here is 1. There's an invisible 1 power there. And our leading term would be negative x to the first. Okay, so that is the leading term. Leading. All right. How about over here? Okay, should be getting the hang of it. You can pause if you haven't. Try this out. Okay, now first thing we want to do is we want to get rid of those parentheses. You've got a negative 1 here, so when that distributes, it's going to change the sign. You got negative 1 times 3y squared. That's negative 3y squared. You've got negative 1 times negative 6y. That's positive 6y. You've got negative 1 times negative 9. That's positive 9. So let's combine these guys. You've got the y squared. You got a 1y and a minus 3y squared. Sorry, 1y squared there. Minus 3y squared. That's negative 2y squared. You got a negative 4y plus a 6y. That's plus 2y. Negative 4 plus 6 is positive 2. Positive 9 plus 9, that's 18. So our degree here is 2. That's this power right there. That's the largest exponent. And the term here, the leading term, is that negative 2y squared. So that's the idea of adding and subtracting. All right? Next, we're going to take a look at some multiplying. What do we do when we multiply? Remember, when you're adding and subtracting, the key is to combine like terms and only like terms.